everybody. I'm going to start today with a story, a dramatic story. So, once upon a time, a new design system arose, enabling design consistency and code reuse while solving problems of accessibility, responsiveness, internationalization, and performance, all out of the box.
While implemented by an infrastructure team with the best intentions. It only considered a handful of use cases. And as the breadth of the product grew and evolved, friction appeared between the creators and those attempting to leverage this single shared component library.
And in some cases, feeling left out by the creators of the library, factions arose. Parts of the organization rebelled and created new versions of the design system that better suited their specific needs.
And finally, even within the product organization, differing goals of performance and design consistency led to multiple camps within the company, each championing a different strategy and vision for the future of the design system.
And so this tale of friction, factions, and forked code is where we begin our story of building the Airbnb design system.
And rebuilding it.
My name is Maja.
And I'm Ty.
And we are both engineers on Airbnb's design system team. Today, we're going to talk about a number of things. First, we'll define for you what we mean when we're talking about a design system, which we'll do quite a lot today.
Yep. Next, we'll go into the evolution of Airbnb's design system throughout the years, highlighting the key decisions and considerations that were made.
And so finally, we'll do a side-by-side comparison of some code examples so you can really understand what the effects of the architectural decisions we made look like in our code base. So, what is a design system? Well, we are, not just as developers, but I think as consumers, really, really intimately familiar with design systems. I think that logos are the tip of the iceberg. You know, a conversation about a design system might start with Coca-Cola's lovely cursive letters, McDonald's arches, Starbucks mermaid, but it becomes really clear that it's not just about the image. It's about the colors, it's about the typography, it's about the spacing, and all of this is the reason why we find brand swaps so funny. I mean, these values are so deeply ingrained in our brains and associated with Coca-Cola that seeing its rival embedded in the same script causes a level of cognitive dissonance that's pretty funny, to be honest.
I just got a little thirsty.
Weird. Now, on the web, we've been using design systems for quite a long time. Bootstrap, material design, tools that we're very familiar with. They're probably some of the most popular open source tools out there. And of course, they're not exactly fresh. They've been around for a while. And back in the day when we were all writing a lot of jQuery, templating languages, so forth, these were based on CSS class names. And this was actually a really good choice for open source projects. After all, Bootstrap probably still powers hundreds of thousands of websites out there, and each of them need to be slightly different. They're associated with a different company, a different brand. And because they use CSS, this technical choice allows for them to be endlessly overridable, themable, extensible, which is really perfect. But for us, with the rise of React, we started thinking about component-based libraries. Those based, we started thinking about rows and form elements, buttons, colors, and typography, each as individual pieces that we could just drop into a page wholesale.
And this is where we come to a spectrum of choices. What kind of API do we choose for our components? On one end, we can use our components as enforcers of our system. We do this by building a strict yet constrained API. This would enforce consistency across our site through our design system. On the other hand, we could build our components to be less opinionated and more flexible. This would make it easy to do tweaks and build new designs using our system, but it leaves the door open for inconsistencies. So where do we go from here, Maja?
Well, let's time travel a little bit and go back to 2015, 2016 to try to understand why we made the decisions we originally did. And so design systems are aligned very closely with UX and product needs. So I think it's important to understand not just what's going on in the technical landscape at this time, but also to take a step back and look at the business. Nice. So in 2016, for us, Airbnb experiences had just launched publicly, and this was a big shift in our app. We were trying to make an update to the site to focus less on just accommodations and more about the in-between of the trip. And this was something that we hoped to do via change to our design language. And from a technical standpoint, there were also a number of considerations that influenced our path forward. Now, this may seem a bit strange now, but we had just come out of a world of massive framework fragmentation, where everything was built with whatever framework the engineer was most familiar with at the time. What were you using in 2015, 2016, Ty?
Oh, around that time, I think I was building my own framework using functional paradigms from Haskell.
Well, in 2016, we had decided as an organization that React was the future of the way we built front end. But despite this decision, much of our site had yet to be rewritten. We had also been dealing with increasing complexity due to our growing organization. Since we were using CSS, we shipped a style sheet containing core styles, maybe this teal button with white text, to every page on the site. But, as I mentioned before, CSS is in and of itself a technical choice, and it leads to certain behaviors. In our case, engineers were overriding every core style pretty much on every page all the time in many different ways. We're also primarily a Ruby on Rails shop, which made it basically impossible to understand where each of these style definitions were actually being used. Engineers had super low confidence that when they made a style update to our core style sheet, it would work as expected across the entire site. And now these are pretty simple examples. I mean, like background color, text color, safe. But imagine styles related to z-index or positioning, and it becomes clear that this can lead to a lot of unexpected behavior. So to avoid this potential downtime, engineers were forced to duplicate code, and often the bugs associated with that code, and that made the problem of complexity grow even more. And finally, performance was becoming top of mind. And while there were tools to optimize JavaScript, either by tree shaking away dead code or lazy loading code not in the critical path, none of these were available for CSS. And the end result was that the amount of unused CSS shipped to every page in our site was growing and growing and growing. And this was seen as a major contributor to our slow page load times. So, fragmentation, complexity, and performance. These were all top of mind from a technical standpoint. And we took a step back and asked the question, what if we could build a design system that helped in each of these scenarios? Well, we had two levers that we could really pull from an architectural perspective: how we build our components and how we write our styles. So for the problem of fragmentation, this was a really easy answer. We build a library in React, and then adoption of the library drives adoption of the React. Amazing. But for the issues of complexity and performance, we had to take a closer look at how we were using CSS internally, see how that could go.
As we all know, global style sheets are both powerful and performant. They're an excellent choice for building a design system. However, we had the prerogative from our design team to enforce consistency as much as possible through the system. We also wanted to feel confident and understand the repercussions of any style updates that we made. And as we heard from Maja's earlier slides, we were not feeling confident about our CSS.
Truth.
So, also at the time, we had begun leveraging performance-enhancing JavaScript patterns like lazy loading and tree shaking, which we saw earlier. So because of this, we wanted to move our CSS into our JS. This would allow us to write styles in line with our components and gave us benefits that we felt were highly advantageous. The first being was that our components were tightly coupled to our CSS. Not only could we write the styles in line with our component files, but it now became easy to add, update, and remove styles without those unwanted consequences we were seeing with our CSS. Changes to your styles would only apply to that component. This was so nice. Another benefit of CSS and JS was that we got the lazy loading and tree shaking that we talked about. We're no longer shipping these huge style sheets with unused styles. We only shipped what was rendered on the page. This was a super nice benefit of going to CSS and JS. A nicety of CS and JS is theming. This wasn't a huge requirement at the time, but we've been relying heavily on this for our China business in all new locales. And finally, we could prevent those style overrides that were biting us in the butt. We were able to rid ourselves of overridable class names and entirely disallow styles for being overwritten. This allowed us to enforce design consistency across the site through our system.
And so this last bit especially is kind of the underlying principle of what we dubbed our design language system, or the DLS. I'm going to introduce this acronym because I can't stop myself from saying it, so now you know it. DLS. I'm going to say it a lot. There were a number of ways that this feature kind of manifested itself, but the most important was the public API that we exposed to users of our system, which in a React world is, of course, our props. And so the easiest way to illustrate what this actually looks like is if we take a look at one of our core DLS components, the button. By default, we ship this beautiful, lovely teal button. If you've used Airbnb.com, I am sure you have clicked on it. But let's say my designer gives me a new design, this blue button. I mean, you know, Airbnb, we're getting into alpaca rentals. We're really eager to differentiate this new product somehow. We want this blue button. It's important. Well, we might be tempted to just pass in a new class name or some dynamic styles that would override this background color. But this was explicitly disallowed by the system. This was precisely one of the issues that we had been having with CSS style sheets. We wanted to have confidence that the button that we built as part of our component library was the same button that our end users would see. So class name styles were out. But what this also meant is that we didn't even allow for slightly less open-ended props, like text color or background color. In fact, the only way to create this beautiful alpaca rental button would be to add a Boolean prop to our core component that would apply all of the relevant styles. And this is because we expected that our centralized design system team would anticipate all possible design needs of the company, and so would build out a complete system from the get-go. I heard some laughs. I know. It's funny. We can laugh now. It's fine. The result of that expectation, of course, is that every addition to the design system, every new blue button begs the question, does this belong? If it wasn't part of the system at the beginning, why are we adding it now? And so returning to the spectrum that we kind of introduced earlier, you can see that we fell pretty far to the left of this graph, on the super constrained side of the implementation. Now, for a time, this was good. Adoption of the DLS skyrocketed, which decreased fragmentation and improved issues of complexity and performance on the site. And product engineers loved it. They lauded the reusability, the consistency. They were excited that problems about responsiveness, accessibility were all taken care of. DLS was definitely the path forward. And the reason that the solution worked so well for us is because we had a design organization that was excited and committed to driving consistency across the platform. But we wouldn't be giving this talk if we had built the perfect design system in 2016. Remember, this is a story about friction, factions, and forked code. And the reality was far different from our expectations. As adoption of the system grew, the pain points actually became increasingly apparent. So, it's 2018. The Airbnb product has expanded significantly, adding new tiers of accommodations, market-specific branding, acquiring new companies, growing into business travel, vacation rentals, experiences, concierge service, peer spaces, and more. It was a lot. And the end result was that what had originally been a design system that supported one product, looked good, wasn't enough. We needed different typography, different colors, different uses of image, different layouts to differentiate each one of these products while still providing a consistent experience throughout the site. But it was clear that the design system just wasn't flexible enough. And what's more, our poor product engineers were largely the ones dealing with this explosion of designs.
So imagine yourself as a product engineer. Imagine yourself as a product engineer in this world of flux. Your designer comes to you with a brand spanking new design and asks you to implement it. How would you go about doing this?
Well, I can think of two options. First, I could create a new component from scratch. I mean, I'm sure the design system has something similar, but it's not exactly what I need, and my deadline is on Thursday, and I really need to ship this feature. Second option, maybe the better one, I could go into the design system and update the code to allow for my new design. But the last time I did this, we got into this massive philosophical debate about, does this belong? Is this a core component? What do you mean? And it's just a lot.
OK, I understand. And both of those options seem very reasonable. Let's go option one. You're on that tight deadline. Let's build that component from scratch. What that leads to is fragmentation throughout the site. A lot of developers are on tight deadlines, and they usually say to themselves, just this one time. But it's not just this one time. And everyone else is doing this too. Yeah. We saw a lot of the same components being built over and over and over again. It's going. There we go. Maybe if I raise it higher. Yeah. The developers of these components weren't getting the benefits that came with using a shared design system, like the shared code, the free, well-thought-out accessibility, and the free maintenance in the long term. So this doesn't feel like the right option. Maybe option two is better, going into the design system and updating our component to handle our new design. So to do this, we'd add a new prop. There we go. That would trigger some design logic, trigger some logic to handle our designs. One or two of these is OK. 3 is OK. But over time, we get lots and lots and lots of these, all baked into a single component. And it ends up looking something like this. Oh, yeah.
This is real code.
Yeah. This is our button component. And it started off being super small, but it grew into this mighty beast that can do a whole lot, but it's super complex to use and maintain. Right? Our component API quickly went from 0 to 100, which in turn complicated our component's internal logic. Oh, man. Woo!
Still going. Look at that. Beautiful.
Can I skip it? OK, thank God.
Cancel it.
Yeah. And because of this, the bundle size of our components grew and grew and grew, and continued to grow until we would stop getting new designs.
Which is literally never.
Yeah. That button component started off pretty small, but it grew up to 33 kilobytes of minified source code. This does not include external libraries. This is a big number for a button. As a developer, when you import this component, and you just want to use your change, you have to import everyone else's code as well. Not only that, but if there's any changes made to this button component in the future, you're getting those too, for free. It's this giant hidden iceberg of code. So none of these options seem super great for developers unless they're using the design system as is.
In my defense, that's what it was literally built for.
This is true. Fragmentation, complexity, and performance. We're seeing these issues arise yet again, just in different forms. So what if a design system could help with these? We're rolling into 2020, the future. Airbnb is scaling rapidly right now and growing many businesses within the company. It's important we can spin these businesses up efficiently and cheaply. What's more, the Airbnb design team is working on a design refresh to move away from this bubbly, colorful look to a more monochromatic design. This will allow our businesses to differentiate themselves through color. We use a design refresh as an opportunity to rethink and rebuild the design system for the future.
And we also really wanted to take advantage of modular architecture, something that React, the framework that at this point powers nearly 100% of our site, was really well designed for. So this next part should be pretty familiar to y'all. To understand the power of modular architecture, let's look at an example. If we zoom in on our date picker modal, which those of you who know me may know this is my favorite part of the site, we could start to split this into smaller pieces. We can extract out the overlay. We could split the modal container from the date picker. And finally, bring out the icons, text, and buttons. And this leaves us with a set of independent components that can be jiggered back together. And this is great, but there's more, because now that we have the individual pieces, we can change where the components go. We can switch out components. And we can remove components and adjust accordingly. And this leaves us with a whole new composition while reusing the vast majority of the underlying pieces. And this gives product teams a lot more freedom to reuse the design system to create whatever it is they need. And this seems obvious. Again, React is literally built for this. But with tons of developers working on features simultaneously, it's easy to build out just what you need and to do it in a non-modular way. I mean, you just add a prop, right? Having a modular architecture is great, but it didn't solve all of our problems. I mean, buttons are like one of these components, and they still got really out of hand.
To solve for that button component that got super bloated, we introduced the base and variance pattern. This is how we create reusable and performant components. Remember that button component that can render any style through its props? The base variant pattern approaches this problem a little differently. It starts by separating out the core logic from the design aspect of a component. This leaves us with the base and many variants. The base defines the component's HTML structure, some generic styling to make it functional, a shared API, and then placeholders. Placeholders are very similar to children and render content in specific locations of your component. Variants, on the other hand, are built using the base and apply the specific design styles, some additional content, or unique logic specific to that variant. It's important to note that developers would import and use variants, not the base component. The base cannot be rendered directly and must first be extended as a variant. This brings us to the interesting yet controversial part of the base variance pattern. All variants live in their own separate files. This leaves us with 4 files: our base component, the base button, and 3 variant files: the primary button, the secondary button, and the tertiary button. All variants share the same core code from the base, have the exact same API, which we see here, but apply their own unique differences in their own files. What this leaves us with is a base component built for a general purpose and can be easily extended. It's important not to tie any design logic to your base, instead providing hooks or placeholders to make designs, to be able to implement designs, to allow designs to be implemented. Variants, on the other hand, are built for a very specific design or purpose. They don't allow style overrides and must be rendered as is. This gives us confidence as maintainers that our variant component will be rendered as expected on the page. By organizing our components in this way, it solves a lot of our problems. First, being that it's super easy to implement new designs. All the hard work's done for you. You just extend a base and do whatever you want to get your specific design needs. There's no reason not to extend a base component when creating new designs. This pattern also makes maintaining components very simple, because not only have we simplified our API and got rid of those style props, we've taken all of that naughty branching logic, those if statements, those tertiaries, and we've straightened it out.
Nice.
Each variant extends directly from the base, so there's no branching logic to deal with at all. Forget about everyone else's code and focus on your own. That's what we like. What's more is that the bundle sizes of our components remain consistently low or stable. Before, you'd have to import all of this code just to get that one style. This caused a lot of bloat when you never ended up using it all. Now, when you import a variant component, you only get what you need. This is super nice. Those small bundle sizes, no 33 kilobytes. One last benefit, and it's my favorite. Because all the variants share the same API, swapping out variants is as easy as updating an import statement. You can easily get your secondary button, your tertiary button, all in one line of code. So in the past, we had major design updates, and we'd apply these design updates throughout the entire site all at once. And some product developers weren't expecting this and did not appreciate the unanticipated changes. This even caused a bug or 2, or 3. Instead of forcing these design updates on everyone all at once, We can now create these designs as new variants, and it opens the door for iterative migrations. This is powerful because it enables the ability to do new designs updates file by file, and giving users of your system control to make the updates, to QA those changes, to A/B test them, all at their own pace. Updating to new designs is as simple as a find and replace. Now, we go back to the spectrum, and we might think that we're moving our design system to be super flexible, but I think we're somewhere in the middle. We continue to be constrained because our variants cannot be overwritten. They must be used as is. But we allow developers to opt out of the system, like an escape hatch, by extending the base and creating new variants if they need to.
So we've talked at a high level about two different approaches to the design system implementation. So let's look at some code to kind of better understand what that actually means. So on this side, we'll start with what I'm sure you think is now our only component in the design system, the button. In 2016, the button was always usable even with no props passed in. It was out of the box, had designs meant to be seen by end users. So we'd have to start with this teal button styles. And so to begin, normal, simple React component, we just want to render a basic button DOM element.
When using the base variant pattern, we start by building a button as well, but it's our base button. No styles are being shipped to the end user that we care about here. We just want to make it functional. So we render this dull gray one. In code, it's actually no different than your normal button at first. They look very similar.
They do. And so next, what we'd want to focus on is the core functionality, things like the on-click handler and anything else related to the DOM or to user interaction. And so here, we just pass in that prop, pass it on to the DOM element.
The base component continues to look very similar when we apply the core API.
But here is where we need to make our button visible to the end user. We need to apply the styles. So this is the way that we wrap all of our components in this React with styles higher order component. And so we define those default styles here.
This is where things begin to differ when we use the base variant pattern. We first mark the base button as extendable and define some base generic styling, our background and our color. What's more important here is that marking this component as extendable defines the component's style API, the button class name. Variants will use this to extend our styles.
And so we, in 2016, would then finally apply those default styles to our individual DOM node. And this, if we stopped here, we could still use this out of the box. We could render this page. Developers have a button that's within the system. Done.
The base variant pattern also applies these styles, just like the button, to our individual DOM nodes. It looks very similar, but because a base component can be extended, variants can apply and override these styles as they choose.
And so in 2016, again, we have a perfectly usable button out of the box. And so for every new variation on this default, we go through the same process. We define the style, we apply the style. We define the style, we apply the style, until eventually we have that long, long, long scrolling GIF from before.
Oh. With the base variant pattern, when we want to create new designs, we create a new file, the primary button file, and define the styles we care about. Notice that we're extending the base button here. As we want to create more and more designs, we create more and more files. This encapsulates all the designs into their own isolated component files. And this brought us the benefits that we saw earlier.
And so there are a lot of trade-offs of both sides, but I wouldn't actually 100% recommend the base variant approach. It's not right for everybody. And so when we look at the single component, the thing we saw off the bat was that performance will degrade over time if you're continuing to add new styles, and the complexity within the components will increase. But this is a big caveat. Everything is in one place. Discoverability of component variations is really high. In the system, when your designer gives you a design and is like, give me a button, you're like, cool, I'm going to go to the design system and look at the one component and see what my options are. Super high discoverability. And then this is less of a, it's not really positive or negative. It's just something that's true maybe about your organization or something to consider. There's more burden on a systems team maintaining a design system implementation in the single component approach, because everything has to be code reviewed and added in. So your design team is constantly working, your engineering team is constantly working to add new features and new designs to your core library.
There are some similar trade-offs with a base variant pattern. Your performance remains consistently strong, and your complexity remains consistently low. These are good things. And we do this by extracting out the shared code into a base component and isolating differences into their own variant files. But this means that we end up with a lot more files. And this can feel wrong to some developers, almost like a burden. They have to go find these files. We use tooling like Storybook to help make using and finding variants a lot easier.
And so for us, there's been a clear winner as to what we need to implement in our design system. But the reality is, whatever is going on in your world is not necessarily the same. And so you may want to pick something else along the spectrum. And so the question is, going from constrained to flexible, when do we use each implementation? I'd say, on the constrained side, if your system's really static, like for instance, you're a contractor coming into a company for 6 weeks, they're going to use that system for the next 3 years, but like no one's touching it, this is a good choice because it creates that brand integrity over time. It's very hard to build something that doesn't look and feel like the brand. Similarly, if the system is small, like for instance, you're only focusing on colors, typography, and like drop shadows, you can keep it pretty constrained because it'll enable that consistency throughout the site, but while allowing a lot of creativity in other parts of it. And additionally, if you have limited design support, you're at a startup, you just hired your first designer, you got 100 engineers all building product every day, you can really increase their impact by having a constrained system. They'll build it once, everyone else will use it, and it'll look good throughout the entire site. And finally, this is something that was really important for us to look at. Engineering cannot be the only enforcers of design consistency. It creates friction between the systems and the product teams. It creates friction between design and engineering. And so only go for a constrained approach if you have support from your product teams and from your designers.
A constrained system is a great way to start. But if your system's starting to notice some of these points, it may be good to move to the opposite side of the spectrum, flexible. One is, if your system's starting to evolve, you're seeing a lot of change, this might be a good time to consider it. Because of these changes, your system's probably growing and growing and growing and becoming large, right? You're trying to handle every permutation of every design in your design system. And that's a lot of work. Add some flexibility and push some of that responsibility to your users of your system. Finally, if you have a strong design team, that can handle the flexibility and use it to flex their creativity, allow them to. And finally, if there's no enforcement of design consistency on the design side, your constrained design system could feel more of a hurdle than an advantage. Give the users what they need.
Wonderful. We hope that you can take our experience from working on the Airbnb design system for many years, apply it back to your work. My name is Maya.
I'm Ty.
Thank you so much.